And for 5-6 with the pre-calc stuff, I'm not sure. I don't usually test on this. I give in the past, a problem set. I'm not quite sure what I'll do with that this year. You'll either have a problem set on it on Wednesday, or I just won't ever test you on this content. Fair enough, but there's not a formal test. Your next actual test will be on the chapter 6 stuff, and that takes us week and a half to do, and then we're done. So kind of nice, we're nearly done. In 5.6, we're going to do some trig with inverse functions. So when you have your 6 trig functions, sine, cosine, tangent, cotangent, all that good stuff, as they stand without domain restrictions, they don't have inverses. Can anyone want to contribute why they don't have inverse functions if I don't restrict their domains? They fail the horizontal line test. Yeah, they all pass the vertical line test by nature because they are functions. By definition, they have to pass the vertical line test. But to have an inverse, it has to be a one-to-one function, so it has to pass both tests. And the trig functions fail, not only just fail the horizontal line test, like they fail it miserably. So fail horizontal line test. So if I restrict the domains, so that I make them pass the horizontal line test, or I make them be one-to-one, then we can talk about their inverses. So the inverses exist, but only within a small window. So the first function I've got up here, this is the sine function. You should be familiar with that for sure, right? And I'm going to restrict its domain so that I can talk about its inverse. If I had it go from 0 to pi, it won't fail as miserably, but it's still going to fail the horizontal line test. So what we do for sine is we take this little part of it and we make that domain restriction. So we don't talk about arc sine outside of that solid blue window. So the domain is negative pi halves to pi halves. Consequently, that's the range of the inverse function, because remember with inverses, x's and y's switch, domains become ranges, ranges become domains, the whole bit. So when I talk about sine inverse of something, I'm actually being given my answer is an angle in that viewing window. All right, so next up, the range of the sine function is what it's always been, negative 1 to 1, and that's the domain of this. One of the ones in your homework today, you're going to be tempted to do, I think it's a cosine one, but somebody tell me why that doesn't make sense. And your calculator won't have it. It's not programmed into your calculator either. It can't do it. Do you know why? When I'm asking you to find arc sine of 1.4, what am I asking you for? An angle who's got a sine of what? 1.4. Why doesn't that make sense? Exactly. It's outside of, you can't get beyond the negative 1 and 1. So when your calculator tells you that there's an error, it's probably because we're outside of the domains. After school yearbook folder. All right, super. Anyway, so let's go do the same thing with cosine. Cosine 0 is 1, cosine pi over 2 is 0, cosine pi is negative 1. We'll sketch it like that. And go ahead and tell me what my domain restriction is going to be so that I can talk about an inverse. 0 to pi, exactly. 0 to pi will be the most obvious. So once you drew that, let's go label that as pi. Let's go bold this in a little bit more. And we're going to restrict the domain to go from 0 to pi. What that means is when I do its inverse, my range will be 0 to pi. Again, they swap, but range of that as it exists is negative 1 to 1. So there's my cosine function. I will restrict its domain from 0 to pi so that I can talk about its inverse. You guys remember what the tangent graph looks like? You ought to, but yeah, it does. Yeah, you're doing it. It does that kind of cubic-y shape, but where are its asymptotes? Let's put tangent on here. Where are the asymptotes of the tangent graph? Why at the pi halves? Yes, if you can, yeah, excellent reason. That's exactly what I was looking for. Sine, tangent sine over cosine, and asymptotes occur where a denominator is 0, and cosine is 0 up at the top of the unit circle and down at the bottom of the unit circle. So when we do the tangent graph, And I know in pre-calc you do a whole bunch of like the transformations of these. We don't really need to work with that in here. We just need to know the general shape and the reasons why, and then we work with their derivatives. Oops, that was a bad, oopsie. The one on the left is not good. That's pretty bad. Anyway, just knowing their domains is great. So the domain for my tangent graph will be the pi halves, negative to positive. How about its range? That's a little bit more interesting at least. What's the range of the tangent graph? Negative infinity to infinity. Yeah, perfect. All right, let's move along here. It says the notation for the inverse functions are, you might be familiar with that, or maybe they use an x for the angle, doesn't really matter, or tan inverse, maybe even an alpha. We don't tend to use that little -1 notation as much in higher levels of math. It can get confused with the reciprocal command. So usually in here you're going to see arc, cosine, arc, sine. Here, every once in a while they'll do that little -1, but it'll be specified. It'll say this notation means inverse so that you don't think it's a reciprocal. It's kind of important that you, let's go in here, understand what the inverse functions give you. If I tell you, hey, watch this. If I tell you 3 squared is 9, is that true? If I use its inverse function, what equivalent statement would I say? Square root of 9 is 3. That's meaning you understand the relationship between the two. So if I tell you that y is the arcsine of x, what equivalent inverse phrase could I say? Now with the square rooting and squaring now is easy. The square root of 25 is 5. There it is. Sine of what? Yes, this is exactly the same as saying the sine of y is equal to x. That's really important that you understand that. That when you're doing an inverse trig function, your answer is an angle, right? So be careful with that. This statement right here is very true. Pi 6 is the arcsine of a half. That's because the sine of it, its inverse operation, the inverse of arcsine is sine, is equal to 1/2. Those are equivalent statements. So let's go down here. It's kind of like me saying x plus 3 minus 3 is x, and you say no, x minus 3 plus 3 is x. All you're doing is using inverse operation to say the exact same thing. When you're trying to evaluate these, right, y equals, I think it's easier if you do that. I'm going to even just write over all of these. If I were to rephrase this, I would do this. The sine of what angle is -1/2? The cosine of what angle is 0? The tangent of what angle is √3? And the sine of what angle is? All of these answers are angle measures. And I think when you get in the mechanics of it, you just go to your calculator and you just do it. All right. So here's my question. If you don't like to think of it like that, do what you do in algebra by taking the inverse to both sides. If there's an x plus 3 and you wanted to get rid of it, you'd do a -3. If there's a squaring and you wanted to get rid of it, you'd square root. If there's an arcsine and you want to get rid of it, you'll sine. So I could say sine of y equals -1/2 if my brain's having a hard time wrapping around it. All right, so the question becomes, the sine of what angle is -1/2? Now, I could go to my unit circle and be a cheater, pumpkin eater, right? And I could look. Is it that one? Is it that one? Is it both? Or is it neither? That's my question. What do you think the answer is? 7 pi over 6, 11 pi over 6, both, or neither? What do you think? Let's go do it on your calculator. Go ahead. See which one your calculator gives you, and then we'll talk about why. So go to your Yes. You see where I'm going with it, don't you? Exactly. Just shut your yap for 1 second. Whoops, sorry. I forget I have this on sometimes. I just said shut your yap. All right. So go to your calculator and make your calculator do this. So we're going to decide, is it one, the other, or neither? Go to your calculator and hit second sine inverse -1/2 And your calculator will tell you what it is. Your calculator is programmed very, very accurately and precisely. Okay, and what does it say that it is? When you did arc sine negative a half on your calculator, it says negative point what? Okay, 11 pi over 6 is certainly not that. That's like 11 times a little over 3 divided by 6. It's totally even positive. 7 pi over 6 is like 21-ish over 6, also very, very positive. But my calculator didn't, the answer to my question when I said, is it one, both, or neither, is actually what? Neither. Because remember, the domain for the arcsine function goes from negative pi over 2 to pi over 2, and your calculator's been programmed that way. So your calculator is actually spitting out what as the inverse? Negative what? Go try it. Go to your calculator and go negative pi, and then divide it by 6. And you'll see that your calculator is not leaving the domain of the function, and it's giving you that. So there's a fine line between you. If you use this unit circle, you're going to have to be far more careful than if you truly understand what you're doing, I think. So the answer to the question over here is negative, right, pi over 6. Now this one's easy. I would, again, you either think of it because you get it. I'm asking you the cosine of what is 0. Or you could just say, I just want to get rid of that inverse trig function. It bothers me. So do its inverse operation, which is cosine, to both sides. And cosine of arcsine is like me saying square the square root. They completely undo each other. So I'm saying the cosine of what is 0? And the answer is either here or here, both or neither. And think of the domain. Which one is it? Pi over 2. Right? And your calculator will give you the decimal version of that. Again, the domain for cosine is 0 to pi. For sine and tangent, it's negative pi over 2 to pi over 2. So that's what your calculator will spit out, and that's what you need to spit out. All right, next one. We'll do it by hand. I'm really saying the tangent of what angle is root 3? And I could write that the tangent of the left is equal to the tangent of the right, and it undoes arctan. So either way. So here's your options. Tangent's domain is over here, negative pi over 2 to pi over 2. I get to eliminate one whole chunk of that right now. Which part? Quadrant 1 or quadrant 4? What do you think gets to go? 4 is not in my answer. Why not? Or my answer is not in 4. That's a bet I had it. Right, tangent would be negative over there because it's sine over cosine, and sine is negative, and so I know my answer's over in this region. I also know if I don't have a calculator, it's a nice hit on the unit circle. I also get to eliminate, there's only 3 possibilities right now, right? Pi 6, pi 4, or pi thirds, those are my only nice hits. Who do I get to wipe out just because I know it's not that one? Pi force is out, right? That's the one we get a lot in Calc 2. We get arctan 1, which means the tangent of what is 1. And what do they replace it with? Pi force. We also get arctan infinity quite a bit, which means I'm saying the tangent of what is infinite? Pi halves. Those are our 2 biggest ones in Calc 2. We rarely come across like this one, but we'll figure it out. This is out for sure because it's got a tangent of 1. I'm either here or here, so you just need to figure out which one it is and not guess. I always remember that there's a half in the far right, and that just gives me the other ones for free. Makes it nice and easy. However you remember that is fine. So I have to decide which one of those when I do y over x or sine over cosine gives me root 3. Top one or bottom one? What do you think? Yeah, the top one would, because I do root 3 halves divided by a half, or I'd multiply by the reciprocal. The 2's would cancel. So my answer is pi thirds. What will your calculator give you for that? Go give it a whirl. Go arctan or tan inverse root 3. And it's going to say 1 point something something. How do I know that? What am I replacing pi with in my head? 3-ish, a little over. So 1 point, what is it? 1.0 0.04. I mean, it's so close to 1. All right, so D is the only one I have to use my calculator on because 3/10 is not a unit circle hit. All right, so you'd have to use your calculator and you'd just do sine inverse 0.3. And I don't know what that is. That's calculator pushing. All right, are we good with that? Just make sure you don't leave the domains. Try not to use your unit circle. And then the next part is some solving. So I already told you these are inverse functions. This is like me saying square the square root, add and then subtract, integrate and then derive. Inverse functions undo each other, so each one of these is x. And we're going to use them a lot. When we want to get rid of arctan, we tan. When we want to get rid of sine, we arcsine. Just, whatever that's the beauty of math. You do whatever you want, as long as you do it to both sides and as long as you always do inverse functions, right? That's totally legal. If you want to get rid of ln, what do you do? E it. If you want to get rid of e, what do you do? ln it. See, the theory holds throughout, no matter how complicated your functions get. So in here, I'm trying to solve it for x, and I hate that arctan's in the way, so I'll tan it, right? And the tangent of arctan undoes it. Where the tangent of pi force, I should know instantaneously. You should know that one. What's tangent pi over 4? 1. Yep. So that leads me to a nice 2x minus 3 equal to 1. And if you can't solve that, you are voted off the island without even any rewards or extra food. You're just gone. Right? Because we have to know that one. Do you know that one? I do. All right. It's 7. All right. Just kidding. Okay. All right, the next one up. This is all going to be about your good friend from geometry, SOHCAHTOA. All right, so you're going to be given 2 parts of a right triangle and need a third to complete your mission. In part A, my mission is to figure out what the cosine of an angle is. Cosine is what ratio? Adjacent over hypotenuse. So I'll get a triangle down. Somehow I'm going to have to be able to get, let's write that down for letter A. I'm going to write cosine y is adjacent over hypotenuse. I will have enough information to figure that out if I can sort it out correctly. So when I have this, that is not helpful for me. SOHCAHTOA isn't arc-SOHCAHTOA, right? I just need sine. So what am I going to do to both sides? Sine it. Yeah, I don't like arcsine in there. It's not part of my repertoire from geometry. So I'll sine it. And the sine of arcsine undoes each other. So I have an angle here that we're calling y. I'm in search of its cosine, but I now know that its sine is x over 1. And sine is opposite over hypotenuse, right? So they're giving me opposite and hypotenuse. Great. I now have that. Let's write over 1. I now know I'm over 1. Problem is no adjacent. How are you going to get that? One of my favorite mathematicians of all time. Actually, he's not one of my favorite. He was a crazy dude, but yeah, he had a whole cult. They were called the Pythagoreans. They were really weird people. Take math history sometime and you'll learn he was really crazy. Google him and read about him. He had something to do with chickens, and he wouldn't walk on one side of the street, and he was weird. Anyway, he did give us our nice Pythagorean theorem, which if you want to set it up and solve it, you would end up saying this squared plus this squared is equal to 1 squared. So you'd have to do 1 minus x squared to isolate. You should be able to do that in your head. So my ratio for cosine, if I were to be doing an odd in the back of my book, is I'd say it's the square root of 1 minus x squared over 1, but we don't put things over 1. How old are you? Not 18 over 1, right? So don't write that. That annoys me. So we would just say my final answer for cosine y is the square root of 1 minus x squared. Done. For letter B, I'm running out of space. You might want to put yours down on the bottom. I'm going to erase all of A so I can fit. Hindsight, I should have given you more space. So let's take a look at what we're being asked to find, and let's walk our way there. Dalton, I need tangent of an angle, which means I need which 2 legs? I need the adjacent and the opposite, and I need to do TOA. I will use this to help me get 2 of them. Unfortunately, I hate arc secant. So to start this off, I will secant both sides. I'll say, well, the secant of the left is equal to secant of arc secant. And you guys do this in does this seem familiar? Did you do it in pre-calc? Yes. So it's coming back. Did I have to teach it or you would have remembered it anyway? I never know. With the pre-calc days, I don't know if you're out there not saying anything because you're bored silly because you remember it all, or you're really paying attention because you don't remember it all. I'm torn. Which one is it? Don't even tell me. I'm just going to keep going. I'm hoping you're just bored silly. Anyway, so in order, back up here, I took the secant of the left equal to the secant of the right. The secant undid the arc secant. I now have two parts of my right triangle. I need to know what they are. All right, so if cosine is A, this is great for ACT, by the way, juniors. If cosine is A over H, what's secant? H over A, it's its reciprocal. So they've handed me a hypotenuse and an adjacent leg. So we'll go throw that on there. Angle in question is angle Y. Hypotenuse is √5. Adjacent leg is 2. That's great because I wanted the adjacent leg. I just now need the opposite. And who's going to get you that? Psycho guy, right? Mr. Pythagoras. We would say a squared, 4, plus b squared, no clue, equals c squared, which is 5. So what's my opposite leg? Uno momento, por favor. There it is. Done. What do you think, Joel? Did it all come back to you? Yeah? Is a good review, Marlis? Not necessary, Billy? Necessary? All right, let's go do 2 more in color day for the most part. So I'm to figure out the cotangent of something. What that means is something is an angle. My favorite angle name is theta. First hour they chose Billy. They actually called the angle Bill. It's kind of stupid as Antilla's idea. Like, why call it Bill? Let's call it theta, right? Or y or something. I need to take its cotangent. I'll go write that over here. Cotangent theta is, tangent is opposite over adjacent. I need to do adjacent over opposite. So, oops, cotangent. Sorry, I said cosine. There you go. Well, let's start. Here's what I know. My angle measure is arc cosine, which I'm now writing with its not as slick notation. That's what I know. And I'm supposed to take the cotangent of it. Uh-oh, hate arc cosine. What do? Cosine both sides. Whatever theta is, its cosine must be -2/5. Now they just handed me 2 legs. What did they hand me? They handed me adjacent and what? Hypotenuse, and maybe you set up the right triangles, but you really don't need to anymore. Again, just make a fake one, and this is adjacent and hypotenuse, and yes, it's -2, and I went to, it just means that if it were actually laid out on the circle, it would have been 2 this way and had a hypotenuse of 5, if you're used to drawing it like that. I don't know how you do it in pre-calc, but either way, go find your missing leg because I need it. Right? I need to do adjacent over hypotenuse. What would be the missing leg? Whether you do it specifically or generically, what's it going to be? What do you think? 4 plus what squared equals 25? Square root 21. Yep, that would have to be a square root 21. Just Pythagorean theorem it. So my cotangent is going to be adjacent, right? Which is -2 over opposite, which is root 21. True or false? I must rationalize my denominator. It's actually false. Go ahead and leave it. If the back of your book does, go ahead, but really all this does is make more work for us because we have to do our calculator anyway to get that, so why bother? I think I told you historically why they did that. All right, let's try one more. I need to take the sine of some angle. Let's pretend it's theta. Let's pretend that theta is actually arctan 3x, and somebody will talk me through it. All right, you ready? Sabrina, what will I do first? Yeah, let's tan the arctan to untrap that. Whoopsie, theta, right? They just handed me 2 legs, right? Opposite over what? Adjacent. Yep, I'll stick with you, Sabrina. What's really on the bottom of here then? 1. So she'll set up a right triangle, correct? Angle in question, we're calling theta. Opposite, we're calling 3x. Adjacent, we're calling 1. How do I get the missing leg? Pythagorean theorem, a squared, 9x squared, plus b squared, 1, is equal to c squared. So let's just go throw that on there. All right, who wants to wrap it up for me? Maddie, way in the back. I was supposed to do the sine of that angle. So what's my answer to the sine of that angle? Yes, there it is. 3x over the square root of 9x squared plus 1. There's several like that in your homework. Last up, because we won't do the bottom one. So when we get into our calculus, who do you think's easier for us to work with calculus? F of x, which is the tangent of the arc cosine of x halves, or g of x? Which one looks friendlier? G. They're equivalent, but g is going to be far easier for us to integrate and derive and all that kind of stuff. I'll show you their equivalent on the calculator. I already have them entered, so don't take your calculator out. I think I have it hidden back here. I graphed them both. The reason you can only see one of them is because they're the same function. So there's my tangent of arc cosine in y1. And in y2, my function of just my non-trig function, when I hit graph, they're identical. Kind of cool, right? That's why you see one function. It's actually the red one's on top of the blue one. Well, mathematically, they're totally the same. Let's go through the same process. I'll start way over there. Colin, I'm going to call this y because with algebra I prefer that. Can you get me started with how I can morph this into that? What's step 1? Yes, let's call this theta if we could just for a second. And let's do theta is equal to, yeah, good enough. Let's just, I don't know if I want to do that. Let's write this. Theta is equal to arc cosine x over 2. I'm not going to arctan because although I could, I think it might make more of a mess. I think I'm going to start in there and say that's my angle that I need to take the tangent of. So I'm going to reboot that. What will I do? What am I going to do to both sides? Cosine it. Yeah, if I could just get a couple legs of my right triangle, that's helpful. And I know that the cosine would be x over 2. I think that's going to be a little easier for me. I can just go plop this on here. Cosine is adjacent over hypotenuse. Missing leg, Kyle. What's this missing leg over here? 4 minus x squared. This is falling out nicely because I was supposed to do the tangent of that. So let's go set it up. My tangent of that angle is opposite 4 minus x squared over adjacent. They are identical once I morphed mine out of trig and into all the algebraic stuff. They're equal. All right, I'm not going to do the bottom. I'm going to give you your assignment, and we have to go do one of them that's been messing people up. We're going to do just odd. It takes about 20-25 minutes. You have about 20 minutes. So you should get the majority of it done. I want you guys to go in and look at number 15 first while I pause this video. If I get over 30 minutes, it doesn't upload well. So if you're watching the video, you'll have to get 15 independently.